Everyone has done that homework yesterday I have given. होमवर्क जो दिया जाता है आप लोगों का फायदा के लिए ना, प्लीज डू इट seriously, okay? So today we have little bit part of damped oscillator. So I'll discuss first relaxation time, then power dissipation and quality factor. Then we'll solve problem, okay? So let us first discuss about relaxation time. So it is basically denoted by tau. So relaxation time basically is the time in which the energy stored in damped oscillator reduced to on by E times of its initial value. So it is a time in which the energy reduces to on by E times initial value, means at this time energy will become E naught by E. So you know that energy stored in oscillator or damped oscillator, that is nothing but Et equals to E naught exponential minus twice beta t, what we have discussed in last class. So at when t equals to tau, at this time E tau will become initial energy stored at initial time divided by E. Okay, so from this expression I can write E naught by E, that should be equals to E naught into exponential minus 2 beta tau. So E naught will be gone. So finally you will get exponential minus, that should be equals to exponential minus twice beta tau. So if you compare the power, exponential power, so you can write 2 beta tau, that should be equals to 1. So from here I can get that conclusion that relaxation time basically depends upon damping parameter. And it is obvious, if damping is high, that relaxation time will be low. What does it mean? So it will very fast, it will lose that energy with very fast, and within a short time that oscillator will lose its energy. So you understood, right? If damping is high, so relaxation time will low, it means the energy stored or energy dissipation rate will be high. This is part clear to all what I'm trying to say? Is it part clear to all? Okay.
सर
Yes.
वो जो लास्ट पार्ट आपने बोला ना कि अगर डी के कांस्टेंट हाई है तो रिलैक्सेशन टाइप, वो एक और बार बताओगे?
हाँ देखो, आपका ये आपका क्या है, डैम्पिंग पैरामीटर. डैम्पिंग पैरामीटर लार्ज है, मतलब क्या है, आपका रेट ऑफ एनर्जी लॉस विल बी हाई, दैट वी हैव डिस्कस, राइट? अगर आपका सिस्टम में डैम्पिंग ज्यादा है, डैम्पिंग फोर्स ज्यादा है, इसका मतलब क्या है, रेट ऑफ एनर्जी डिसिपेशन विल बी हाई. तो एनर्जी डिसिपेशन हाई मतलब क्या है कि वेरी शॉर्ट टाइम में क्या हो जाएगा, आपका एनर्जी विल बिकम्स ई नॉट बाई ई. ठीक है ना? सो it is very clear because damping parameter decide if damping parameter is high, so within a very short time that oscillator will lose that energy and it will become E naught by E. Now is it clear?
Yes sir.
Okay. Okay, now next small part, that is power dissipation. So it is basically denoted by P. So power dissipation means it is rate of loss energy. So power dissipation is basically defined as a rate of energy loss. So why I am using minus sign? Because it is basically denoting the energy is basically getting less, or energy is reducing with time. So power dissipation means rate of energy loss, and due to loss I have used this minus sign. Now you can write, you know that E is what, basically E is this, right? So from this, if I use this, or what I'm trying to say, if I differentiate this E with respect to time, I'll get 2 beta E of t. Okay, it is very clear because E is basically how much, so you can write from here Et will become minus E naught, and you will have minus twice beta exponential minus 2 beta t. Okay, so minus minus will become plus, so it will be 2 beta E of t, and you know 2 beta is what, actually this is nothing but b by m into E of t. Okay, so there are different form. So rate of or power dissipation or rate of energy loss can be defined like this. It can be defined like this also. In addition, you can define, so this is capital P, I am using capital P symbol here. In addition, just I have calculated that 2 beta is nothing but 1 by tau. So you can use this formula also, that rate of energy dissipation or power dissipation will be Et divided by tau. So there are different form of power dissipation. It can be represented like this, it can be represented like this, it can be represented like this. So they may give you that beta, and they may provide you relaxation time, and they may ask for dissipation. So there are different forms. Okay, is this part clear what I'm trying to say?
Yes, sir.
Okay. Okay, next small part, that is, इतना लिख लिया आप लोगों ने? Is it clear everybody? Because this, you know, this small part is very important for your exam point of view. It's a very small part, but it is very important. Okay, so if you have written, then I should erase this part, and we'll go to that quality factor. Shall I erase?
Yes, sir.
Okay. आप लोगों ने होमवर्क क्यों नहीं किया हो?
क्योंकि ये तो आंसर नहीं आ रहा है।
आंसर नहीं आ रहा है? कहाँ नहीं आ रहा है? चलो नेक्स्ट क्लास में मैं डिस्कस करूंगा. आज मेरा हेल्थ उतना ठीक नहीं है, शायद मैं छोटा ही क्लास होगा आज आप लोगों का. Okay, so now we'll discuss quality factor. So quality factor is basically defined as 2 pi into energy stored divided by energy loss in each cycle. Okay, so what I can write, 2 pi energy stored is nothing but E. and energy loss in each cycle. So that, how can we define? That is nothing but power dissipation into time period, where P is the power dissipation and T is the time period. So this is basically energy loss in each cycle. So if you multiply that energy dissipation with time period, that basically defined energy loss in each cycle. And just if you remember, just now we have seen that power dissipation is nothing but E divided by relaxation time, and you have time period. So these things will be cancelled. So what you can get from here, 2 pi times tau divided by T. Okay, 2 pi times tau divided by T, and 2 pi by T. T is your time period. So 2 pi by T, what can I write? So this is the angular frequency. So I can write here, angular frequency for damped oscillator is omega 1 into tau. Okay. So further, I can write, in place of tau, I can write twice beta, right? Omega 1 into twice beta. Okay. And also, we know what is twice beta. So I can write omega 1 into m by b. So this is the form. Okay. Is this part clear what I'm trying to say? So 2 pi by T, that is your angular frequency for damped oscillator, that will be omega 1. And tau, you know, that is related to damping parameter, that is 1 by 2 beta. And 2 beta, we know 2 beta is nothing but damping coefficient into mass. Okay. Okay. Now, if damping is very low, so damping is very low means what? Beta tends to 0. So in that case, I can write omega 1 equals to omega naught. If you remember, omega, that expression for omega naught was, omega 1 was how much? That was omega naught square minus beta square. So if damping is very low, it means beta tends to 0. So in this scenario, omega 1 will become omega naught. So what I can write, quality factor will become omega naught into m by b. Is it clear what I'm trying to say?
सर ये पी क्या है यहाँ पर? पी
Yeah.
पी 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 ऊपर साइड में, साइड में, साइड लेफ्ट हैंड साइड,
Yeah.
ऊपर वाले में पी,
ये T.
ये पी साइड में पी.
Oh, P. Okay. Actually, your voice is not clear. So P, just now we have defined. What is P? P is actually power dissipation. So if you just look at just previous discussion. So P is nothing but energy dissipation, rate of energy dissipation, or you can say power dissipation. So if you see power dissipation, just now we have derived, that is nothing but energy stored divided by relaxation time. Okay, and this will be cancelled. Relaxation time will go upper, and 2 pi by T, that is nothing but angular frequency. Under damp case, that will be omega 1, and tau, you know, that is relaxation time, that is related to damping parameter, that is nothing but 1 by twice beta, and further twice beta is nothing but b by m, where b is your damping coefficient and m is the mass of the block. And further, when the situation is damping is very low, it means beta tends to 0. So you can approximate omega 1 equals to omega naught. So in that scenario, quality factor will become omega naught m by v. Okay.
Yes.
Now is it clear? Is it
Yes,
clear?
sir. Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Shall I erase? Shall I erase?
Yes.
Yes, sir.
Okay. So let us solve few interesting problems. So your damped oscillator, you have damped oscillator. Okay. So first problem will be, you have damped oscillator and energy loss energy loss per minute, that is given as energy loss per minute that they have provided you 1%. Okay, energy loss per minute, that is 1%. And the question is, what will be the percentage of decrease in amplitude per minute? Okay. So percentage of energy loss per minute, that is provided you 1%. And the question is, then what will be the percentage of, this is representing percentage. So what will be the percentage of decrease in amplitude per minute? And that your system is damping oscillator. So how will proceed for solution? Any clue? How will proceed?
Yes, sir.
कैसे proceed करोगे? Okay, so we know that relation. If you remember, energy d energy stored, that is a function of time, and that is nothing but E naught exponential minus twice beta t. So if you differentiate with respect to time, it will become d by dt. Okay, that will become minus twice beta. Okay, e of t. Okay, if you differentiate this equation with respect to time, it will become minus twice beta e of t. So percentage of energy loss per minute, how will represent? So that is, so percentage of energy loss is nothing but d by e into 100, right? And per minute means dt. dt will be how much? 1. So basically they have provided you, this part clear? You see, this is the percentage of energy loss, t by e, and per minute means dt you have to take 1, right? So if you rearrange what they have provided you, actually de by e, that d I have bring left hand side, and you have dt also, and that is nothing but minus twice beta. So percentage of energy loss per unit time, percentage of energy loss per unit time, that per unit time is per minute, that they have provided you 1%. So 1% means what? Basically 1 by 100. So from here you will get minus 2 beta, that will be 1% means what? 1 by 100. So percentage of energy loss, that is d by e per unit time. So dt here they have provided you, that is how much 1 minute. So I have taken dt equals to 1. So that means minus 2 beta is nothing but 1 by 100. So now I will use this minus twice beta, okay? Or what I can say, from here I can write beta is nothing but 1 by 200. Okay, so it means, so if this is a scenario, we know amplitude of oscillation is depends upon time, that is nothing but a naught exponential minus beta t. So it means if you differentiate this with respect to time, dA by dt, that will become minus beta into at. So what they ask you actually, dA by a into dt, that is how much in percentage they ask you. Okay, so we know beta is how, minus beta is how much, 1 by 200. Minus beta means 1 by 200. So percentage means you have to multiply it by 100. So it means 1 by 2% means 0.5%. So it means the percentage of energy loss, if it is 1% in 1 minute, okay, the percentage of decrease in amplitude per minute will become 0.5%. Okay, this is part clear what I am trying to say all? किसी का कोई क्वेश्चन है इसमें, इस पार्ट में? प्लीज रेस्पॉन्ड मी. Do you have any question here?
No, sir.
Did you understand this part?
No, sir.
Everyone, Karthik, Himanshu, Shekhar?
Yes, sir.
Okay, understood, right? Okay. Okay, now let us solve another interesting problem. Shall I raise?
Yes, sir.
Yes, sir.
Okay. Problem number 2. तो आप लोग सब 2023 के लिए प्रिपेयर कर रहे हो ना सारे लोग?
Sir.
Yes, sir.
Okay. Second problem. So you have damped oscillator, its natural frequency is given omega naught, that is 100 radian per second. Okay, and solution of damping equation, that is they have provided you displacement as a function of time, and that is x naught on plus omega naught t into exponential minus omega naught. So your damped oscillator is natural frequency that is on 100 radian per second, and solution of damped oscillator that provided you xt equals to x naught on plus omega naught t into exponential minus omega naught t. Now question is, at what time damping force will be maximum, FD will be maximum? I will proceed. Yes, any? कैसे प्रोसीड करोगे? Okay, so let us first write what is your damping force, that you know, minus B into V, right? And V is nothing but dx by dt, right? So this force is maximum means del F D by del T, that should be 0, right? So it means B is some damping parameter that cannot be 0. So what is the conclusion? Del square x by del T square should be equal to 0. Just if you differentiate with respect to time this equation, B is constant, that your damp case, so it cannot be 0. It means del square x by del T square, that should be equal to 0. And you know x here, okay. So just I'll differentiate 2 times and I'll equate this this equals to 0. So if you differentiate x with respect to time, how much you'll get? So first you'll get minus omega naught x naught on plus omega naught t, then you will have exponential minus omega naught t. दिखाई दे रहा है आप लोगों को ये पार्ट?
Yes, sir.
Okay. What about second term? So second term you will get omega naught x naught exponential minus omega naught t. Okay. Again, if you differentiate with respect to time, so it will become del square x by dt square. Okay. So if you differentiate this equation, so first you will get x naught omega naught square, x naught omega naught square, then you will have x naught omega naught on it. Let me write this side, it's not writing properly this side. This side I write. Okay. So del square x by dt square, that will become, so first if you differentiate, it will be minus x naught omega naught square exponential minus omega naught t. Okay. So I'm differentiating this term first. So there is 2 term here. So I first differentiate this term. So it will become, if you differentiate with respect to time, that will give you omega naught, and you have omega naught here. So it will become x naught omega naught square exponential minus omega naught t. Now I'll differentiate this part. I'll keep this as a constant. I'll differentiate this part, and that will provide you x naught omega naught square on plus omega naught t into exponential minus omega naught t. Okay. And you also have this term, right? And this is your actually plus sign, right? So that will give you x naught omega naught square exponential minus omega naught t. Okay. So if you solve it, you will get omega naught square x naught on minus omega naught t exponential minus omega naught t, that you will get. Just if you simplify this term, you know, on x naught omega naught square will be cancelled, and if you take omega naught square x naught common from the rest of the part, you will get this kind of scenario where x naught that they have provided you, that is non-zero value, omega naught that is also non-zero, this part cannot be 0. So but you know, that is for maximum force, that del square x by del t square, that should be 0. So this cannot be 0. X naught that is constant they provided you, that is non-zero value. This exponential function can never be 0. It means this term can be 0. So what is the conclusion? So if you substitute this equals to 0, it means 1 minus omega naught into t, that should be equals to 0. So t should be equals to 1 by omega naught, and omega naught that they have provided you, that is 100. So it will be 1 by 100 second. 1 by 100 second. So at this time, your oscillator will have maximum damping force. Okay. Is it clear to all? Is this clear?
Yes, sir. Yes, sir.
Do you have any question in this question? किसी का कोई डाउट है इसमें? Everyone? सबको समझ में आया ये क्वेश्चन?
Yes, sir.
Okay.
Sir,
Yes.
we are finding d square x by del t square, right, sir?
Yes.
For that, in the first term, shouldn't it be plus?
This term,
Yes, sir.
you see, from here I am getting, right?
Yeah.
So just I have differentiated this part with respect to time. So it will give you omega naught, right?
Okay.
So that's actually this term. Second time, what I have done, this I kept as a constant, just I have differentiated this part. So this will give you minus omega naught and you have minus here. So it will give you plus term. So this term, if you differentiate second part. And further, this is your, if you differentiate this term with respect to time, that will provide you this term. So now on x naught omega naught square will be cancelled. You have this and plus you have this. So that will be cancelled. So you have two more terms. If you take minus omega naught square x naught common, so you'll get inside bracket you will get 1
Okay.
minus omega naught t and
Okay,
you have
okay, sir.
uh,
Thank you, sir.
okay. So now another question I'll do, and that will be interesting. Suppose question number 3. Suppose there is a viscous medium. There is a viscous medium. Okay, this medium is viscous. Okay, a particle of mass m that enter this medium. Okay, a particle of mass m that enter this medium and it experience only damping force. Only damping force is experiencing. Okay. Also, they have provided you when time t equals to 0, velocity of this particle is v naught. So now what will be the plot between v and t? I mean velocity of a particle as a function of time with time. कौन सा curve follow करेगा? Again I am repeating, there is a viscous medium. A particle of mass m is entering this medium and it is experiencing only damping force. Okay. Initially, when it enter at time t equals to 0, its velocity is v naught. Now we have to make a plot velocity of particle as a function of time. Time के साथ इसका plotting कैसे होगा? Okay. That you have to check. Did you get what I'm trying to say?
Yes, sir.
Velocity of particle as a function of time versus time plot करना पड़ेगा आपको. कैसे इसका curve कैसे बनेगा? So I'm giving 4 option also. Suppose v and t. So will it be like this? Second option. Will it be like this? Third option. Will it be like this? And last option is, will it be like this? Okay, so I'll proceed, and this kind of problem is really important for your exam purpose. So particle is only experiencing damping force, right? And you know damping force is how much? Basically FD equals to minus BV, right? And you know force is nothing but M dV by dt, and that should be equals to minus dV. Okay, so it means dV by V equals to minus d by M into dt. Now if we integrate at time t equals to 0, its velocity is V naught, right? Velocity is V naught, and time t equals to t, velocity is Vt. So if you integrate dV by V, say its integration is natural log of V. Now if you substitute this limit, it will provide you Vt divided by V naught, and that should be equals to minus Bt by M. Okay, with some constant. You can take some constant also. No constant will be there, because already you have substituted that limit, so no need to consider any constant here. So it means Vt equals to V naught exponential minus beta t by M. So it means the velocity of your particle due to that presence of damping force will decay exponentially. So this is not exponential function or exponential decay. This is also not exponential decay. This is not exponential decay. So correct option is this. Okay. Is it clear? Okay. Okay. Now LCR circuit. So you know that LCR discharging of LCR circuit is also behaves like a damped oscillator. So suppose you have LCR circuit. LCR circuit means you have capacitor, then you have resistance also, okay, and you have inductance also, okay. LCR circuit में तो तीनों component होता है, right? LCR. So this is your capacitor, this is your resistance, this is your inductor. Inductance is capital L, resistance is capital R, capacitance is C. अब discharging of LCR circuit means क्या है? आपने एक पावर सप्लाई कनेक्ट करके इस कैपेसिटर को पूरा फुल चार्ज कर लिया है ना, जब इसका दैट टाइम योर की इज ओपन, ठीक है, फुल चार्ज कर लिया आपने, अब की को आपने बंद कर दिया, तो फिर क्या होगा, जो आपका चार्ज स्टोर्ड है वो फ्लो होना स्टार्ट करेगा. इट मींस इट विल प्रोड्यूस करंट और करंट विल स्टार्ट फ्लोइंग, राइट. सो लेट अस अस्यूम फॉर एनी इंस्टेंट ऑफ टाइम कि कैपेसिटर में प्लेट में आपका चार्ज कितना है, क्यू है, Q1 minus Q, right? And let us assume that current is flowing in this circuit is I. Okay, so your current is flowing in the circuit because initially you have charged this capacitor, and after charging you close this key. So when you are charging this capacitor, your key is open, so no current can flow or charge cannot flow. After full charge, you close this capacitor or key, so now there will be sudden flow of charge, so there will be flow of current, right? So potential drop about C or capacitor will be how much? Vc will be how much? It will be nothing but Q by C. Potential drop across capacitor. Across resistor, VR will be how much? That will be IR, right? And across inductance or inductor, VL will be how much? That will be L di by dt. That you know, right? This thing you know. Now if you apply Kirchhoff voltage law, KVL theorem, So according to Kirchhoff voltage law, sum of the potential drop in a closed loop, that should be equals to how much? 0. And sum of the potential drop means potential drop across capacitor, across resistance, across inductor. So if you just substitute this value, so I'll first substitute that value of VL. VL is nothing but L di by dt. Then I'll substitute IR, that is potential drop across your resistance, that will be IR, and potential drop across capacitor, that is Q by C. That should be equal to 0 according to KVL theorem. And I know that I is nothing but dq by dt, right? I is nothing but dq by dt. Okay, so if you substitute that in place of I, if you substitute dq by dt, also if you divide this equation by L, then your equation will become, कैसे इसका इक्वेशन का फॉर्म क्या बनेगा? डेल स्क्वायर क्यू बाय dt स्क्वायर प्लस r by L dq by dt, and you will have third term, that will be q by LC, that will be 0. इस इक्वेशन से क्या पता चल रहा है? Anyone? What you can get from this equation? So see, is this derivation clear to all?
Yes, sir.
सबको समझ में आया?
Yes, sir.
Okay. So what is this equation actually?
Simple harmonic motion.
In simple harmonic motion, you don't have any dq by dt term, right? So you see, this is a kind of damping. So you have del square q by del t square, I mean del square x by del t square, then you have dx by dt, right? So you see this equation representing damping oscillator, right? Because you have dq by dt, that is also present here. If you have only del square q by del t square and this term, then this will be simple harmonic motion. But this term, due to the presence of this term, this will be damped oscillator. This is part clear what I'm trying to say?
Yes, sir.
Yes, sir.
So this the discharging of LCR circuit is actually your damped oscillator. Okay, so discharging means you fully charge your capacitor, then you close your key, current will start flowing. So if you apply Kirchhoff voltage law, then you will get the equation of damped oscillator. So discharging of your capacitor in LCR circuit should behave like a damped oscillator. Now what will be the frequency of oscillation? Anyone? So it will be, if you remember, frequency of oscillation omega 1. So omega 1 was how much? Omega naught square. So what about omega naught here? 1 by LC. And beta square, we have beta here, so that will be R square by L square. The frequency of oscillation, this part is also used to teach in electronics part also, but here I showed you that frequency of oscillation you can calculate from damped oscillator itself. So is this clear how I have written this omega 1? Because if you remember, omega 1 was how much? Omega naught square. So here omega naught square will be how much? The coefficient of Q, that will be 1 by LC. And beta will be how much here? Beta will be how much here? This will be your 2 beta, right? So I think there will be 1/4 here, if you remember. Because 2 beta equals to how much here? 2 beta equals to your R by L, right? So beta means R by 2L. And if you remember, omega 1 was how much? Omega naught square minus beta square. So beta is nothing but R by 2L. So it should be R square by 4L square. Is this clear what I'm trying to say, everyone?
Yes, sir.
Okay. Okay, if you understood, please do one problem. I'll provide you one problem. So you have LCR circuit and कैसे चल रहा है आप लोगों का प्रिपरेशन?
ठीक चल रहा है सर।
सबका ठीक चल रहा है, बाकी लोग?
यस सर, ठीक चल रहा है।
अच्छा, क्लास में मजा आ रहा है आप लोगों का? आर यू एंजॉयिंग क्लास, एवरी क्लास?
यस सर, यस
Yes, sir.
ओके
Yes.
ओके गुड, ठीक है, अच्छे से मेहनत करो, है ना? चलो, okay, now let us solve one problem, because you see this kind when they will deal with the LCR circuit, they will used to provide very simple question, but this thing you should understand that your LCR circuit can also behave like a damped oscillator. So they have provided you a LCR circuit and also they have given some data. So you have LCR circuit, okay. So they have provided you the value of inductance, they have provided you how much. Okay, do it at home, okay. Two, also they have provided you capacitance, that is they provided you 2 microfarad, okay. The resistance they have provided you 2 ohm, okay. This will be your point on Henry, okay. So this parameter they have provided you, okay. So you have to calculate the frequency of oscillation will be how much. So that I'm not doing because this part is very simple, you can do at your home. So inductance they have provided you 0.1 in SI unit, capacitance they have provided you 2 microfarad, and R they have provided you, that is 2 ohm, okay. So you have to calculate the frequency of oscillation, okay. I think you should do, because this is nothing, that's just parameter I have given, just you do that calculation and send me, okay. So this is your this is all about your damped oscillator. I think this is sufficient. Okay, now next part I'll discuss bit about your forced oscillation, because we don't have that much time, but let us, so you can do this part, right? Can you able to do, everyone? Nothing is there, just you have to substitute this nothing is there.
Yes, sir.
You do it properly, okay. And you didn't do yesterday homework also, please do it properly, because you are preparing for 23, so you have to be focused, because जो स्टेप आपको करने के लिए बोलते हैं वो आपके भला के लिए ही बोलते हैं ना. You should do it properly, okay. Now the next part is your forced oscillation. So forced oscillation means, suppose you have damped oscillator. You have damped oscillator with some medium, okay. ये आपका डैम्पिंग का केस था. अब फोर्स्ड ऑसिलेशन का मतलब क्या है कि मैंने ब्लॉक को पकड़ा हूँ बाहर से और उसको मैं फोर्स दे रहा हूँ, ऑसिलेटिंग फोर्स दे रहा हूँ. And that oscillation that is governed by force that is providing outside. So I am providing that force, I am catching this block and I am oscillating this block. So I can tune that frequency. Whatever frequency I want, I can provide, right? So what I am trying to say, forced oscillation means you have damped oscillator and that force that is provided from external source to oscillate this system. So what does it mean? That I am catching this oscillator, I am stretching it, I am compressing it. So that force I am providing, that is itself a oscillating in nature. So clearly you can must claim, or you can understand, if I am catching this oscillator and I am providing that force to stretch, I am providing that force to compress. It means that force oscillation, first of all, it will be oscillatory in nature. Second conclusion is that the force of oscillation should be in same direction of displacement. So that net force, what I can write, you have damped oscillation, damped force, you have restoring force. In addition, you have external force, right? So damped force and restoring force, that is actually opposite, acting opposite side, but force that you are providing, that is acting in the same side of displacement. So what I can write from here itself, the net force will be minus kx minus bv, and you have plus some oscillating force, and let us define this force, that is f naught sine pt. So this is plus because this is acting in the same direction of displacement, and also you can clearly see this force is oscillating in nature. Okay, so I am applying force to bring it to stretch it, I am applying force to compress it. So like this. So in this way I can make the frequency of oscillation how much I can. So आप अपने हिसाब से इसका frequency को आप और number of oscillation को बढ़ा घटा सकते हो by changing that force. क्या ये कॉन्सेप्ट आप लोगों को समझ में आया? फोर्स ऑसिलेशन का मतलब क्या है?
साइन पीटी समझ नहीं आया था.
अच्छा, ये पार्ट समझ में नहीं है आप लोगों को?
सर
यस सर.
ये पार्ट समझ में क्यों नहीं आया? देखो, डैम्पिंग फोर्स तो इधर काम कर रहा है और रेस्टोरिंग फोर्स ऑपोजिटली काम कर रहा है, और एफ नॉट साइन पीटी दैट यू आर प्रोवाइडिंग दिस फोर्स फ्रॉम एक्सटर्नल सोर्स, मतलब इसको आपने समझ मान लो, इसको आपने कैच कर लियो इस ब्लॉक को, और आपने बाहर से इसको फोर्स दे रहे हो, मतलब आपने बाहर से इसको ऑसिलेट करवा रहे हो बाय गिविंग ए ऑसिलेटिंग फोर्स. तो देखो फोर्स का जो डायरेक्शन होगा वो डिस्प्लेसमेंट जिधर होगा उसी डायरेक्शन में होगा, राइट? ये जो फोर्स है ये क्या है? एक्चुअली एक्सटर्नल फोर्स. सो यू कैच दिस ब्लॉक एंड यू आर ऑसिलेटिंग. So this force, you can say this force is itself oscillating in nature. I'm catching this, I'm oscillating this. So force is actually oscillating in nature, and its direction is same as the direction of displacement. So that's why you have to take positive sign here. Where P is your driving frequency. अभी समझ में आए या नहीं?
यस सर.
अच्छा, जिसका डाउट था उसको समझ में आया? नहीं?
यस सर.
आ गया? Okay. What is P here? P is nothing but driving frequency. P is nothing but driving frequency. Okay, so if you simplify this equation, if you bring this term this side, so I can write what I can write, d square x by dt square. So in place of f net, what I can write, ma, right? And ma is nothing but m into d square x by dt square, and that m, whatever is m is there, I'll divide both sides. So you have ma here, right? F net is nothing but m into a, and a is acceleration, I can write acceleration like this, and whatever m I have, I'll divide this side. So I'll get this kind of term, 2 beta dx by dt, and you will have third term, that will be omega naught square x, and that should be equals to small f naught sine of dt. So you say, you see, this is that you people know, this is your equation of damped oscillator. and these things actually coming from external force, and where F naught is what actually? F naught is nothing but capital F naught by M. So this is your equation. Just I have divided by M. Now you know K by M is nothing but omega naught square. You have X, B by M, that will be 2 beta dx by dt, and F naught by M, that will be small f naught sin pt. So this is your differential equation under force oscillation. We do not have that much time, so we'll discuss this part tomorrow. Okay, tomorrow we'll discuss this part. किसी का कोई question है?
No, sir.
Everybody?
सर
Yes.
सर ये वेव्स एंड ऑसिलेशन के लिए कौन सा बुक रेफर करना चाहिए?
अच्छा, वेव्स एंड ऑसिलेशन के लिए सुरेश
हाँ
गर्ग
सर।
का एक बुक है ना, सुरेश गर्ग. So you can use this book.
ओके सर।
If you are preparing for JAM, did you get that study material?
नो सर,
You didn't get study material?
वेव्स एंड ऑसिलेशन का नहीं मिला है।
अच्छा अच्छा, मिल जाएगा शायद. मिला आज? कुछ मिला नहीं आप लोगों को स्टडी मटेरियल?
मिल गया है सर।
सॉफ्ट कॉपी?
कुछ सब्जेक्ट के लिए मिला है।
सॉफ्ट कॉपी नहीं मिले आप लोगों को? Okay, I'll ask to Satish sir. He will provide you. Okay. And
Okay,
we kept many questions there in study material. Please do that question seriously, and that will be more than sufficient for your exam. Okay, please do it seriously. I kept many questions there in worksheet. Please do it. Okay, do it
Okay,
yourself. Okay, okay, okay. I should stop here.
थैंक यू सर।
Thank you, sir.
yes, sir.